Alright, let us continue with Adaboost. Yeah? So we've seen bagging. Now we're gonna start with boosting. And the first one we're gonna discuss is Adaboost. Yeah? Here you see that boosting you do when you have a bias issue. But it's not only a bias issue, you also will have variance. Yeah, boosting will also deal with variance. And how will it deal with variance? Is by limiting depth of the trees. Yeah. So that's how boosting will also tackle variance issues. So we derived this formula. So basically you have a strong classifier that's going to be built up by a set of weak classifiers, H1, H2 and so on. And this classifier's influence will be taken care of by the alphas. Yeah? Alphas give the voting power of the classifier. It's quite intuitively that if your classifier is not so good, yeah, high error means alpha will be small. Yeah. So let's take a look at it using an example. This is going to be a quite simple example. We will discuss a bigger example after this session here. But basically we have about 10 points. Yeah, you see 5 pluses, 5 minuses here. And the HIs here are decision stops. These are simple lines. And basically what we're going to do, we're going to start with setting the weights for all these points at 1 over n. Yeah, 1 over n means in this case 1 over 10. The same for all the points. Yeah. The next step we're going to take is we're going to pick the best weak classifier. Yeah? That means we're going to pick the classifier that makes the lowest error. So in the first case, what we will do is we will make H1 this classifier. And we're going to build up h of x equals the sign. Yeah? And then we're going to fill it. So this is H1. What we do next is we look at the points that are misclassified. The points that are misclassified are these 3 here. These 3 pluses. And what we're going to do in the next phase is to increase the weight of these 3 misclassified points. You see the pluses here are bigger. Yeah? And we're going to reduce the weight of the points that are correctly classified. So here are all the minuses, yeah, small ones, and 2 small pluses here. Yeah, so we have H1, and H1 will lead to an alpha 1 of 0.48. Yeah, don't worry about these numbers. Yeah, so it's 0.48 times the first weak classifier is H1, so that's going to be the one that classifies like this. Now we have increased the weights of the 3 pluses here and decreased the weights of these minuses and these 2 pluses. So now we're going to look for the next best classifier, best weak classifier. And this weak classifier will be here, which will be H2. Yeah? So the alpha in this case will be a bit bigger. Yeah? And alpha in this case will be, so alpha 2 will be 0.66. Yeah? So we do plus here, 0.66. And the classifier that we use is this one. Okay? So here again, now we're going to look at the points that are misclassified. Yeah? These are all correct. So the ones that are misclassified are these 3 minuses here. Yeah. So we go from here to there. So now what we're gonna do is increase the weights of these minuses and reduce the weights of the points that were correctly classified. Yeah. And here you can see that if you want to make a decision boundary between these two, the decision boundary is going to be between the 3 plus cluster and the 3 minus cluster here. They're quite dominant and high weight. So your next best classifier will be H3. Yeah. So we add here plus, and the alpha here, the alpha 3 will be 0.92 or something. Yeah, will be quite high. Yeah, and this is then the last classifier here. Okay, and we do that times 0.92. Yeah, and now I claim that we're done. Yeah. Now I claim that we're done, and I'm gonna show that here in this one. So we have our 3 H's here. Yeah, we had these 3. This was H1, this was H2, this was H3. Okay, so let's take a look at the 2 pluses here. Here they were positively classified by H1. By H2 they were also positively classified. And here they were negatively classified. But you see that 0.48 and 0.66 is larger than 0.92. So these two will be correctly classified as plus. Yeah, so they are on the positive side, which is left or on top. Yeah, so we can already draw that line. Then let's take a look at these 2 minuses here. Here they have been correctly classified, here they have been correctly classified, and here one of them was wrongly classified. But these 2 will again overrule this one when it comes to the 2 minuses on the edge. Yeah? So what we're gonna have here is we're gonna have a minus here and we're gonna have a minus here. Yeah? So they will be on the negative side. So let me draw the line here, yeah, because now we're gonna look at the 2 big ones here. Yeah, here the pluses were wrongly classified, but with an alpha with lower weight. Here they were correct with a big weight. Yeah, so it's clear that this zone will be plus. Yeah, 3 big pluses here, and for the minus the same thing. Here they were correct, here they were wrong, and here again they were correct, but with a very high weight. Yeah, so 0.48 plus 0.92 is going to be bigger than the 0.66. So here you're going to get your 3 minuses. And the decision boundary basically goes like this. Yeah, and we're done because now all these points are correctly classified. And that's why we make the statement that we're done in this case.